Philip has been asking me about the inner workings of a drill. The fact that you can switch speeds, increase, decrease the switch by switching it. It has a clutch. At one, the torque is very low. At the other end, the torque is extremely high. So we're basically just gonna take it apart and see what's inside. But before we do that, maybe a short explanation. So Philip, can you, let's set this up at one and see if you can actually drive this screw right into that 2x4. No, you cannot because something happened. There's a clutch that limits the torque, right? So let's see, try number 3, see what that does. So there's more torque, but still, okay, how about all the way? 13. Oh yeah, goes all the way. Okay, so there are different settings on that clutch, and pretty much we drove it all the way through. There we go. Okay, so now Philip's gonna attempt to take that old drill apart. So there's a few screws that we have to take out, and we'll see what's inside of that. Okay, let's just keep that for the future reference. So basically the idea is to figure out all the components, name all the components, and maybe we'll do some calculations as far as if we find any gears, we can calculate the ratio. Just one more? Mm-hmm. Cool. Alright, so now, let's see if you can split it. You know what, I think you have a couple more at the bottom. Or maybe one, see? There's one more over here. And then another one. Do you want me to hold it? You got it? Okay. Okay, so we got this last bolt out. Let me see, okay. Well, I guess it doesn't really matter. Now I'll try to split it. Okay, just be careful. You don't want any springs or any. Just set it on one side. Okay. So let's take a look at that. Ooh. So what do you think, Philip? Where's the electric motor? What do you think? Okay, where's the transmission or gears or no?
Over here.
Okay, and then the clutch that. Changes the torque. Okay, that's over here. So it's pretty compact design. Let's see. We can even try. Let's see. Put the battery back in. Does it work? Oh, the battery is dead. But see, it's trying to. The motor is trying to rotate, or spin. Okay. That comes out.
Transmission.
See, remember, here's the switch. See, that switches from high speed to low speed.
Oh.
Okay, see? So that little motion.
Yeah.
It's transferred. It does something inside that makes the spindle rotates at low speed or high speed. Okay? So for now, we can take it out. Take the whole thing out. Let's see.
Oh, you're going to take the whole thing.
Yeah. Whoa, here you go.
Oh, very dusty.
Yeah,
and
no,
then how
it's been in
does
use
this work when you...
forever. Well, that is the electrical switch to reverse the speed. So it's not really mechanical, it's more electrical.
Would it still work if I were to put this in and it...
Yeah, try it. See?
Oh.
It works. the battery is dead, and we don't even have a charger for that old
Type of battery.
drill. Yeah, for that type of battery. But okay, so I guess now we need to keep on exploring, and maybe we'll clean it up a little bit, and then we'll try to take the whole thing apart.
Okay.
Okay, so Philip is trying to clean it a little bit. Oh, and at the same time you disassembled it. Okay.
Just a bunch of gears inside. I can see that.
Well, the
rotate.
gears on that side, so that's the transmission. So you were correct. That is the transmission. But here's the electric motor, and it basically has a little pinion. So we can we'll try to calculate the actual ratio for those two different speeds. Okay, so we just discovered that there is a bolt inside a chuck that needs to be removed. I don't know if it's visible, but looks like a Allen wrench. So all right, I gotta get Allen wrenches, and I'll be right back. Okay, because the chuck is so old, there's no way of removing that nut, so we have to drill it out. We have our handy drill, so let's see if we can do that. All right, just do some drilling.
Okay.
I'll hold it, and you drill just right in the middle of that thing. Okay, so we got the bolt out. Apparently it's been Loctite, so that's why it was so hard to remove it. So let's see if we can pull the chuck out now. Okay, so we're trying to remove the chuck, and we are improvising a little bit. Let's see if this works. Put that down. Use this Allen wrench inside. Can you hold this, Philip?
Yeah.
Hold that. Okay, did it go?
Yeah.
Alright. So we have the chuck out. Let's pull this pin out. And that's probably gonna we're gonna gain access to the inner workings of the gearbox. Philip, can you remove this pin? You know what I'm talking about? The pin. This. Just watch your fingers. Oh, good job. Good. So now the clutch, probably. Okay, now we can take this nut. See, spring. So this spring is responsible for that torque, increase and decrease in torque as you operate this clutching system. See, and those little teeth inside, they correspond with this nut, and this kind of travels back and forth, compressing and compressing that spring. Okay. Yeah, that's very important, Philippe, what you're doing. All right, let's get to the bottom of this. We need to extract that gearbox. So, any ideas? How do we go about that?
Maybe try to pull it out, or...
It seems like a one part. Do you see any clips? Any? Let's just remove this metal. Okay.
My charcoals.
See, because the screwdriver has a magnet, so that's why it tracks all those shavings. Okay, we remove the clutch, the clutching system. Let's put that aside.
Very dirty.
Very dirty. That's. Oh, there's a pin. See, it looks like a pin. Where's the long? Can you pass me that
Yeah.
tool? Thanks. Let's see. Actually, there are two of them on both sides. So let's see if we can. Oh, see, it comes out.
Came out.
The other one. Here we go. So we have those pins. See, let's see. Oh, here we go. Look at that. Beautiful. Beautiful planetary gearbox. Yeah, actually 2. See? Set of 5 planets. Those are called planets. This is sun, called sun. And these are planets. And then there's a ring around it. And so, where's the motor? Okay, so the motor, that's the sun for the initial planetary set. Then this sun fits into this planetary set. Oh, actually, so we have
very crazy.
three sets. See, that's the first set. So these are the planets for the first planetary set with that ring gear. Then we have another ring gear for these planets. And then the whole, and here's the carrier for that, and this sun goes into that planetary, and then this is the final drive. Okay, so see, Philippe, this is how the clutching is accomplished. It has those little teeth on the outside, and then there are teeth inside. I don't know if it's easily visible. So then when you move, when it's in this position, it's not engaged, but if you move it all the way to the bottom, it engages with the housing. So housing never moves. It's just you engage or disengage that second planetary gear set. Okay. All right. So let's count the teeth on all of those gear sets. Okay. So we were able to calculate the number of teeth on all those gears included in those 3 planetaries, and we counted it 3 times, so I think we got the numbers correct. Here are the results. So we have a motor, which is basically a sun gear to the first planetary, then we have the first ring, then we have a second sun, the second ring, and then third sun and third ring. So here's the input pinion, which is 17 teeth. That goes into this first planetary, and here's the ring. So that works like that. It goes here. So obviously the next step is going to be for us to calculate the ratio. And the ring does not move, it sits inside this gearbox, and then there is the secondary gearbox, which is the speed reducer, additional speed reducing. You achieve that by clutching this ring or declutching it. And then there is a output planetary, and that goes to the chuck. Okay, now we got to do some math. So the formula to calculate the ratio is pretty simple. If you look at that, it's just a tooth count on the sun, right? And this is for the planetary, plus the tooth count of the ring divided by number of teeth on the sun. Okay? Or you can do this, you can simplify this. So it's just, it would be 1 plus number of teeth in the ring divided by number of teeth in the sun. Okay?
Okay.
So let's do the first stage. So we've got 17, and the ring is 54. So 54, 17 equals 54 divided by 17 equals 3.17 plus 1 is 4.118. We can just round it to 1/8.
Okay.
Okay, that's the first stage. Then the second stage is 50 divided by, where's the sun number 2?
Right there. It's
So
20.
that's 20. 1 plus, that equals 50 divided by 20 equals to 2.5. So what's the ratio?
2.5.
Right, plus 1.
3.5.
Genius, really.
Quick math.
Yeah, that was very quick. And then third stage,
Yeah.
1 plus ring number 3 is 50.
50 plus 20. I mean, the same thing.
Same thing, so pretty much exactly.
3.5.
So the ratio is gonna be 3.5.
Quick math.
So we have calculated the ratio for each of the stages. One is the first stage is 4.18, the second stage is 3.5, and the third stage is the same, pretty much 3.5. So, and then second stage is either engaged or not. So you include that in the calculations or not. So for the total ratio, to calculate the total ratio, you basically multiply 3.18 times 3.5. How much is that, Philip? Shall I use calculator?
Yes. Because I am stupid and I will not be able
Hold
to
on.
calculate.
4.18 times 3.5. That is 14.6. 3. That is the
Ratio.
that is one ratio, and then for slow speed times 3.5, we increasing the ratio to 1 to 51.205.
Wow.
So that's the first ratio. The second is 51.205. And according to the manual, this drill operates between 450 and 1500 RPM. So if we use that ratio, if we use that speed, so which one is higher speed, 1500 or 450?
1500.
So if we use 1500 times 14.63, we have an input speed of 21,945. So the motor speed is M equals 21,945. And let's double check. 21,945 divided by 51.205, and that is the low ratio. I mean high ratio, high torque, low speed equals 428. Okay, so we're pretty close. Maybe we missed 1, 2 here and there, but so the high speed is 1500, low speed is 428. So, and that's how you calculate ratios in for planetary gearboxes. It's always the number of teeth in a ring divided by number of teeth in a sun plus 1, and that's your ratio. And then if you have multiple stages, you just multiply them. I mean, multiple stages, you multiply the ratio, and you get the overall total ratio. Okay, Philip, good job. So now I know how the cordless drill works. Just don't take this one apart.
Okay.
Hi everybody, this is a quick addition to my original drill disassembly video that we did yesterday with Philip. After editing the video, I realized I did not really explain the process of shifting gears very well. The whole concept of shifting between one low speed, high torque and high speed, low torque position on the drill. So I just wanted to quickly go over that and explain that. So what I did, I made a cutout on a housing, so it would be probably better to kind of visualize the process. So we have, once again, quickly, input pinion, which is the sun gear, to the first stage. Here's the first stage ring, first stage carrier with 5 planets, and output pinion, which in turn becomes a sun gear for the second stage ring, and this is the shifting plastic ring. And then we have a third stage stationary ring with the output carrier. So the whole process of shifting happens between when the shifting ring gear is either attached to the housing or floats. And then if I put this quickly together, the first stage and second stage, you can see that in this configuration the second stage ratio is included in the overall ratio of the system. So the first planetary ratio times the second planetary ratio times the third planetary ratio gives you that 1:51 high-speed rotation. But if you move this backward and engage the carrier of the first stage, you, in essence, you eliminate the second stage from the ratio calculation, because then it becomes a one unit. So there's no really, you're not introducing any ratio at the second stage. So then it's just the first stage times the second stage. I'm sorry, first stage times the third stage. So now I'm gonna try to put it together and show you the difference. And here's the whole system assembled together. High ratio. And now if you shift it, low ratio configuration. Hopefully this helps you understand the inner workings of a cordless drill. And thanks for watching.